right, and here we go. Our last example of hypothesis testing for means. Still using the p-value approach. So the example states that we are interested in testing whether the mean age at onset of anorexia nervosa in young women has been decreasing. Assume that the previous mean age at onset was 15 years old. Data was gathered from 20 young women who were admitted for the eating disorder. Assuming the sample distribution is normally distributed, test this with a level of significance of 0.05. So, we are interested in testing if the mean age has been decreasing. Assume the previous mean age at onset was 15 years old. We gathered data from 20 young women. Assuming that sampling distribution is normally distributed, we haven't actually seen that yet, but that's a really good thing for us to see. The previous ones we've had large enough sample sizes, however, that we haven't had to worry about that. And we're going to test this with a level of significance of 0.05. So everything that I have underlined so far has been 15, 20, and 0.05. So 0.05 is my alpha, 20 is my n, and 15 is the assumed previous mean age, so that would be mu. I was not given an x-bar or a sample standard deviation, an S value. However, I was given the ages of the 20 women. I was given the data, the raw data for the 20 young women. I have 20 ages here that I can see in front of me. These are the ages that these women were when they were admitted. So I can go and find the mean for these 20 women and the standard deviation for these 20 women using an Excel book that we have from the past. Our summary statistics Excel book. We haven't used this one in a while. But this one will take a data set and it will give us the sample mean and the sample standard deviation. It has sigma on here, but if you recall, Excel doesn't know whether your data came from a population or a sample. You needed to know that. This is a sample, not the population. So what I'm going to go ahead and do is I'm going to go ahead and type in all of the ages into my workbook. And hopefully not mess any of these up. I'm trying to go fast so that this video is not super long. Oh, but I messed something up. All of you watching this are probably like, she messed that up right when she said she wasn't going to. Okay, 15, 14, 16, 12, 16, 15, 14, 13, 14, 12, 14, 13, 17, 13, 12, 11, 12, 14, 15, 16. Okay, there we go. And then if I just scroll over a little bit, I see X bar is 13.9 and S is 1.6512. If I want more than just those, I can try and make that column a little bit bigger, but it actually won't let me. I thought I made it so you guys could make that bigger, but apparently not. So we're just going to work with what we've got here. So if you are presented with raw data, The problem doesn't tell you what the mean and the standard deviation are. It gives you the 20 ages. You can go in and you can calculate the mean and the standard deviation for the data set. And then you continue with the hypothesis test as you normally would. So you write out your null and your alternative. So our null is that we are assuming, let's put some color on the page. We are assuming that the mean age is unchanged from 15. But we are interested in testing whether the mean age has decreased from 15. So we have a left-tailed test. Now, so step 2, once we've written out our null and alternative, is to calculate our test statistic, which is a t-score, which is the formula x minus mu over s over the square root of n. X bar, we calculated from the data, 13.9 minus 15 divided by 1.6512 divided by the square root of 20. So the top is negative 1.1. The bottom is 0.3692195444. Again, I'm wanting to keep as many of those decimals as I can, just to be on the safe side as I'm working through this. Whoopsies, where did I go? There I am, okay. And negative 1.1 divided by all that fun stuff is negative 2.9793 when we round that properly. Okay, I'm still seeing a lot of not rounding happening. We need to see rounding happening. Make sure you're rounding. So then we're going to calculate our p-value. Oh, again, this was still the hand-by-hand calculation of the test statistic. And this will be the by-hand calculation of the p-value using Excel. So I don't need this anymore. I just need a blank workbook. So in my blank workbook, I'm going to do t.dist. I'm going to enter in the t-score, followed by my degrees of freedom, which remember is n minus 1. So our n is 20, which makes our degrees of freedom 19. And then this one, t.dist, when you're doing a left-tailed test and it's t.dist, we do have to put true at the end, because this is what you would use if you ever for some weird reason wanted just this probability, which I would never ask you for, and I don't know any situation when you would, but this is what you would use. You never would. So negative 2.9793, comma 19 for degrees of freedom, comma true, because I want everything from negative 2.9793 and below. I don't want just negative 2.9793. I want everything less than it. And we get 0.0039. That's our p-value. I didn't write that when I wrote the 3. Remember, the p in p-value stands for probability, so your answer should start with 0 point something. If you ever write something other than 0 point something, double check and make sure your answer is not in scientific notation, because it probably is. It's probably a very small number. So let's just go ahead and check this in our Excel workbook that we have been using, this inference workbook. Make this a little bit bigger so we can see this. So this is the 3rd page of that inference workbook. So the null hypothesis is equal to 15. The alternative is also equal to 15, but it's not a two-tailed test. It's less than. 13.9 was the sample mean. 1.6512 was the standard deviation. Our sample size was 20, and our alpha is 0.05. And using Excel, we get the same answers. So as a reminder, you can use Excel unless you are specifically told to do something by hand. So this takes us to our last step. Minimize that. Actually, I can just get rid of that. Whoopsies. So we're on our last step. Make this nice and big. We are going to write out our conclusion and our interpretation. So the conclusion, is our p-value too small? What's too small? Anything less than alpha. So is 0.0039, that was our p-value, less than 0.05? Well, let's see here. I have a 0 and a 0. I have another 0 and a 5. The 0 in my p-value is less than the 5 in my alpha. So, yes, which means I reject the null. And I'll come up here and we'll cross it out. So this guy is false. This guy is true. So an interpretation, what does this mean? I've rejected the null. What does it mean? There is sufficient evidence to conclude that the mean age of onset of anorexia nervosa in young women is less than 15 years old. So we can conclude that the mean age is less than 15 years old. Now this is one that I want to add something at the end of this. This is a complete hypothesis test. This is where you could leave it. But I want to talk really quickly about the implications of this. If I am doing this hypothesis test and I am part of an outreach program, and my outreach program has only been going to high schools to talk to young women about eating disorders and about nutrition and, being good to your body and exercise and all of those things. This hypothesis test shows that waiting until high school means that we are getting to them too late. If the mean is 15, remember the mean is about the middle. So that means about 50% of young women who are going to become anorexic are going to be anorexic before they are 15 years old, which for a lot of them means before they hit high school. So if I'm part of an outreach program and I'm waiting and our program only goes and talks to high schoolers, this hypothesis test could be brought to the leaders of the organization to say, we need to start going to middle schools. Because this test, these results prove that the mean age is less than 15, which means we need to start talking to these young women younger. We need to start teaching them how to take care of their bodies younger. Because if we wait until high school, it's too late. And they're already becoming anorexic. So, this is how a hypothesis test can be used. It can be used in a lot of other ways as well. But this is one really big example that I always want to make sure that I point out. Like, this is a major implication of something that could be brought to someone's attention from this one. So, that is the last hypothesis test that we have an example of. And yeah, there you go.